So the next one. Find the number of arrangements of the letters of the word independence. In how many of these arrangements? First part, do all the words start with P? Second part, do all vowels occur together? Third part, do all vowels never occur together? And the fourth part, do the word begin with I and end with P? So we will take the word independence. In this independence, how many letters are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there are 12 letters in the word independence, isn't it? The next thing you have to check whether any letter is repeating or not. I is not repeating. N repeats. How many times? 1, 2, 3. So N repeats 3 times. What about the next letter E? E repeats 4 times, isn't it? Again, D repeats 2 times. And all other letters are distinct. So N repeats 3 times, E repeats 4 times, and D repeats 2 times. And the first question is, in how many ways do all the words start with the P? So altogether there are 12 letters, and there is a restriction for the first letter must be P. How many places we have to fill? There are altogether 12 places. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Already P is filled, isn't it? So how many ways it is possible? It is possible in 11 factorial divided by, we have to avoid the repetition, isn't it? So avoiding the repetition, N must be avoided. So 3 factorial into 4 factorial into 2 factorial. Okay, so the first answer, in how many ways do the word starts with the P? So starting with P means we just have to complete the 11 letters. So 11 letters can be filled in 11 factorial ways. Since the repetitions are there for N, E and D, we have to divide with 3 factorial, 4 factorial and 2 factorial. Okay. Again, going to the second one. Do all vowels occur together? Which are the vowels here? I is a vowel, E is a vowel, but E repeats 4 times. That means out of these 12 letters, 5 are vowels. And the question is, the vowels must occur together. So 5 vowels are there and 7 consonants. Okay, if 5 vowels must come together, how many places we have to fill? 1 place for the vowels and the 7 places for the consonants. 1, 2, 3, 4, 5, 6, 7. So altogether how many places we have to fill if the 5 vowels must come together? 8 places. Okay. So in how many ways it is possible? These 8 places can be filled in 8 factorial divided by, repetitions are there, isn't it? Vowels E, no need to take E. Why? Because it came under the heading vowel. So it can be avoided. The other letter repeating are N and D. N repeats 3 times, D repeat 2 times. So that you have to divide. So the number of ways will be 8 factorial by 3 factorial into 2 factorial, in which 8 places can be filled. 7 for consonants and 1 for all the 5 vowels together. Again, in how many ways 5 vowels can be filled? In how many ways 5 vowels can be filled? 5 factorial, isn't it? There are total 5 vowels, and out of these 5 vowels, E repeats 4 times, isn't it? If repetition is there by the theorem, what we have to do? We have to divide it with the number of times it is repeating. So 5 factorial divided by 4 factorial is the number of ways in which 5 vowels can be arranged, or number of ways in which 5 vowels come together. Okay, so what is the required number of ways? Required number of ways means vowels must come together and also all the letters must be used. So vowels together means it can be done in 5 factorial by 4 factorial ways, and 8 places. 1 place for all the 5 vowels together and other 7 for the consonants can be filled in 8 factorial by 3 factorial into 2 factorial ways. So required number of ways, that means total number of ways by fundamental principle of counting, what we can say is will be equal to 5 factorial divided by 4 factorial into 8 factorial divided by 3 factorial into 2 factorial. Okay, so this is the answer. The third part is to find the number of arrangements in which all vowels never occur together. Never occur together. We have to find the number of ways in which vowels never occur together. That will be equal to total number of ways in which the letters can be arranged minus number of ways in which vowels come together. Isn't it? Total number of ways we got from the first part as 12 factorial divided by 3 factorial into 4 factorial into 2 factorial. How 12 factorial came? There are 12 letters in the word independence. 3 times N repeats, 4 times E repeats and D repeats 2 times. That is how total number of ways became 12 factorial by 3 factorial into 4 factorial into 2 factorial. From that, what we have to subtract? We have to subtract number of ways in which vowels come together. That part we have done in this answer we have found in the second part, and that answer we got as 8 factorial divided by 3 factorial into 2 factorial. Okay, here you have to calculate. This value will be 1663200 minus 8 factorial. After simplification, you are getting the value as 16,800. So if I subtract these values 0, 0, 4, 6, 4, 6, 1 will be the answer. 1646400 will be the total number of ways in which vowels never occur together. Okay. Again, the fourth part is we have to find the number of arrangements in which the word begin with I and end with a P. The word begin with I and end with a P. So there are altogether 12 letters. Already these two are fixed. So how many places in between must be filled? 10 places, isn't it? So how many ways it can be done? 10 factorial divided by, again, which all are repeating? I and P. I independence. I is not repeating. I is coming only once. The same way P also comes once. The repetition letters are E, N and D. E repeats 4 times. So we have to divide with 4 factorial. N repeats 3 times. So we have to divide with 3 factorial. And D repeats 2 times. So divide with the 2 factorial. So the number of ways in which the word starts with I and ends with the P is equal to 10 factorial by 4 factorial into 3 factorial into 2 factorial. So here if we simplify, 10 factorial can be written as 4 factorial into 5 into 6 into 7 into 8 into 9 into 10 divided by, again, 4 factorial into 3 factorial is 1 into 2 into 3. 2 factorial is 1 into 2, isn't it? So 4 factorial get cancelled. 3 into 2 gives you 6. 4 into 2 gives you 8. So the answer will be 5 into 7 into 4 into 9 into 10. And the product will be 12,600. Okay, so the number of words or number of arrangements in which the words start with I and ends with the P is 12,600.